It's Steve here again, doing another FreeCAD 1.0 for Amateurs video. This is a redo of one that I just did because I thought I would make it a bit simpler on making a 3D printed parametric screw-top container. We had made a screw-top container in an earlier video, but I wanted to redo it so that I can show how to use the varset function to quickly change the size of the container to meet your needs. I'm going to leave this splash screen up for a bit because you might want to take a picture of it or make it a copy. Essentially in this video, we're going to actually proceed with how to do it without ever making a sketch. We're going to use, for the body of the container, an additive primitive cylinder, a threaded rod for the threads, and a subtractive cylinder for the inside. The top of the container will be another additive primitive cylinder and a metric tap. We will be principally in the part design workbench with going into the fasteners workbench to provide the threads and the threaded rod. In doing a project like this, you can of course define the parameters as you go along. But because I had done a technical drawing and had worked it out, I have already decided what my varset parameters would be. That is, those parameters which will be used during the creation of the primitives and the threaded rods, which will provide our ability to make those changes quickly. And I will discuss that a bit as we go along. So the varset parameters we're going to make up front because it will make it easier to follow as well as quicker. We're going to define a body diameter and a body height for our outside dimensions. The threads on the bottom of container, meaning the threads on the top of the container, you know what I mean. We're going to define the body thread height, which will define ourselves, which is basically the distance above the top of the container that show the threads. We'll also define threaded rod height, which is actually the body thread height plus a millimeter. And we have to do that because the threaded rod we're going to use has beveled bottoms and tops. And we want to sink the threaded rod into the container to cover the bottom beveling. And then of course we have to define the threaded rod diameter. The threaded rod diameter of course can be set by you, but for the purposes of this video, it'll be the body diameter minus 4 millimeters. That means there'll be a 2 millimeter lip by which we can then seat the top. And we'll then cut out the inside of the body with another subtractive cylinder for the inside. And the top, of course, will be a cylinder with top diameter and top height. Okay, well, let's go ahead and get started, and I'll just show you quickly what we're going to do here. So here's what we're going to be making. Okay, outside cylinder, threads, inside cylinder. All right, well, let's get started. I'm going to bring this over here. I didn't mean to. I'm going to use this as a reference. So let's go ahead and open up FreeCAD 1.0. And I'm on a Macintosh, of course. All right, so here we are in FreeCAD 1.0, and let's go ahead and get started. Well, since we've already done the technical drawing offline, let's just go ahead and set all our varset parameters right now so we can add them in as we're building the model. So in FreeCAD 1.0, here we have the varset parameters. We click on it once and we can now name it. As I said earlier, we've got body diameter. Has to be one word. Help if I actually spelled it correctly, wouldn't it? Body diameter. Okay? tab through the different values, and let's just make the diameter 40 millimeters. Okay, we're going to add another one, and this will be then the body height. Tab, 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 for now 40 millimeters. We're going to now add body thread height, which is, like I said, the distance above the top of the bottom, which is the height of the threads. Body thread height, tab, tab, tab. And we're going to set this value for now for 5 millimeters. It doesn't have to be, but it could be whatever you want it to be. Then we're going to define the threaded rod height, tab, tab, tab. Now this we're going to make 1 millimeter larger than the body thread height, because like I said, we're going to sink the threaded rod into the body. So in the values, we're going to go ahead and make an expression, and we're going to refer the body thread height. So we type in varset to bring up our varset. We're going to bring in the body thread height, and we're going to add 1 millimeter. Okay. Then we've got the threaded rod diameter. Tab, tab, tab. Now the threaded rod diameter you can define, but like I said, to make a 2 millimeter lip around the container, we have to reduce the diameter by 4 millimeters. So let's go ahead and in the expression editor, varset, body diameter minus 4 millimeters. Okay? And that will create a 2 millimeter lip outside of the threaded rod. Okay? Now moving on then to the body inside, we're going to define the inside diameter. Now the inside diameter is going to be the container inside. So we've already reduced the body diameter by 4 millimeters to make the lip for the top to sit on. So we better make the inside diameter even smaller than that. So for the purposes of this video, tab, 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 we're going to call up the expression editor, reference the body diameter again. So just type in varset and use my down keys, the body diameter. But this time we're going to take away 8 millimeters. So we're going to be 2 millimeters into the beginning of the thread, 2 millimeters more in to start the inside. Okay? Now we're going to create the inside, the height, right, of the subtractive cylinder on the inside. Call it inside height. The value, again, call up the expression editor, varset. And it's going to be, as you might imagine, it's going to be the body height plus varset, the body thread height. Okay? Now, obviously, the inside is going to have to be raised up a bit. We'll show that as we build it. Okay? Now let's move on to making the top parameters. We got, of course, the top diameter. Oops, misspelled. Top diameter. Tab, tab, tab. Expression editor by either clicking the little guy off to the side or hitting the equals button. Varset, which of course is the body diameter. So the outside of the lid, of course, has to be the same side as the body diameter. Okay? Okay. Now the height of the top, top height, tab, tab, tab. The top height can be basically whatever you want it to be, but for the purposes of creating an integrated piece, I'm going to make the top 3 millimeters greater than the threads. That gives me a millimeter to add extra threads for a tight fit, and then the top then being 2 millimeters thick. Okay, so once again, expression editor, this little blue guy here, or equals sign, varset. We're going to reference the body thread height and add 3 millimeters. Okay? Now we're going to define also the tap. The size of the tap that we're going to use on the top. As I've explained before, in 3D printing, if you create a 8 millimeter threaded rod and an 8 millimeter tap, it won't work because of the inconsistencies and the errors built into 3D printing. So the tap must be slightly larger than either the die cut or the threaded rod. And in MicReality Ender, that magic number is about 0.8 millimeters. So the top threads, top tap diameter, tab, 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 expression editor, varset, down arrow, the threaded rod diameter, and we're going to add 0.8 millimeters. Okay? So that really, I think, is most all of our variables that we will reference. So now let's get on to building the model. Well, we're going to start in the part design workbench. And the first thing we're going to do is we're going to add an additive primitive of a cylinder. That's the outside of the box. We will anchor it by clicking on the XY frame, XY plane, I mean. The radius, now this is interesting because remember we defined diameter in our varset, but that's because I think in diameters, but the cylinders are in radius, so we've got to take that into account. So let's go ahead and point the radius to the varset. Okay, how do we do that? Well, we click in the expression editor, we type in varset, select it, and we select the variable in the varset that we want to make the radius. Except now we've got to divide it by 2, don't we? Right? We've got to divide it by 2 because it's a radius here, but we defined a body diameter. Of course, you could have done the radius and saved yourself the divided by 2, but I think in diameters, okay? The height, formula editor, varset, body height, okay? Okay, and now we have defined the outside of our container. Click OK. All right. By the way, if you click on the varset, you will see all of your defined variables. Those in white are those that you set personally. Those in blue are calculated as we did the calculations as we developed the varset. Okay, so now we have to put on top of the cylinder the threaded rod. And as I explained, we're using a threaded rod from the fasteners workbench. We're going to give ourselves a threaded rod, and that's because we could have done a cylinder and used a die, but the threaded rod's already beveled on the edge. Okay, so let's go ahead and select in the fasteners workbench. Oh, I picked the wrong workbench. No, I didn't. I picked the right one. We got to find our threaded rods. Where did our threaded rods go? Scooby-Dooby-Doo. This is interesting. My window changed since last I used it. Huh! So we're going to have to go find ourselves threaded rods. Unless my eyes deceive me, where did they go? Well, this is peculiar. Fasteners. We'll do it the hard way. Add a threaded rod, and I'll figure out why my screen changed later. We will add an ISO Screwtop metric threaded rod. Okay. All right. So here we got our threaded rod, and the threaded rod is always placed on the XY plane, but is downward. Okay. So let's click on the threaded rod. The diameter, remember, we're going to make equal to the body diameter minus 4. So we have to now create a custom. The diameter custom, we're going to open our expression editor, varset, threaded rod diameter. Okay? Give it a second to do its thinking thing. Oh, it changed. See, it's funny on a Mac, sometimes things just get changed. Remember, we already select custom, but it took it away. Yeah, it's weird how this happens. So now we have to move the threaded rod in the Z direction so it's buried but still doesn't show the bottom bevel. So we're actually going to move the threaded rod up in the Z direction. Expression editor, varset. We're going to move it up the height of the threaded rod height. Okay? Give it a second to do its magic. So what did I do wrong? Oh, that's because, guess what, guys? I didn't set the length. The length here is then going to be varset. Sorry about that. Yeah, you get to see how I make mistakes as I'm doing it and forgetting about things. So the height of the threaded rod is what we've defined as the threaded rod height. Okay? Okay? So because I am dumb, we have to go back to placement. And the position then isn't the threaded rod height. It is, in fact, it's actually then varset body diameter plus varset threaded rod plus body thread height. Okay? Got that? Not body diameter. Boy, I'm making a ton of mistakes today, aren't I? Let's go again and do this again. Z, varset. Maybe it's good for you guys to see how I make mistakes. Body height plus varset body thread height. And that should move now the thread to the top, but burying the bevel. Okay? Let's go ahead and make the thread so we can see the thread. Give it a second to think its thing. Okay. Now, let's go back to the part design workbench, because now we have to hollow this out. How do we hollow it out? We hollow it out by adding a subtractive cylinder to the middle. But if we add a subtractive cylinder, it will not subtract from both the cylinder. Well, let's call that, let's rename that to outside. Okay? Okay? If we add a subtractive cylinder now, it will not subtract it from both the threaded rod and the outside. So what we have to do is we have to fuse these into a single body. Okay, so we're going to fuse them into a single body, which is now this. And we can rename that for clarity, outside and screw rod, okay, or whatever we want to call it. Okay, forget my typing. Now, because we have a single body, we'll be able to place the subtractive cylinder inside this combined body, and it will work. So we'll go ahead, bring in a subtractive cylinder. We will reference the bottom XY plane. The radius, expression editor, varset. The radius will be the inside diameter, remember, -6. Whoops, except guess what, guys? I didn't divide it by 2, right? Radius versus diameter. Okay? The height, varset, will be the inside height. Okay? Now you'll notice that we now have to move the subtractive cylinder up 2 millimeters to give us a solid bottom. So in the attachment editor, we are just going to go ahead and move it up in the Z direction 2 millimeters. Okay? Now that that's all done, we can click OK, and we can see, in fact, we now have our hollowed out Screwtop container. Now I want to make a comment here. I want to go back to the outside Screwtop and go back to the threaded rod. You're going to find that the pitch of these threads may have to be adjusted. I left it at 1 millimeter, which is the default. In my printer, 1.25 works a little bit better, but that'll be completely up to you about what works best for your printer and how many turns you want to place on the lid. You can do this and it will work with 1.0. It's just mine works a little better with a little bit wider thread. Okay, so now we're ready to do the top. We're in the part workbench. We're going to create a new top. We will call this the top. Okay. And under here, we will create a new additive cylinder. Oh, I'm going to make the body, I'm going to hide the body while we're working on the top. So there's the top, an additive cylinder, enter an expression, varset, top diameter, divided by 2. I won't forget this time. Okay. The height, varset, top height, which is the thread height plus 3. Okay. And we click OK. We've got our top. Now we have to tap the inside threads. So it's back to the fasteners workbench. We'll go to fasteners since, like I said, I can't really figure out why my screen has changed, but I can worry about that later. So let's see, add inserts, add thread washer, add pins, nuts, ground screws, set screws, cross, tools. Oh, why are we not finding our right fasteners here? So we're going to use the screw tap, right, rather than the DIN threaded rod. We're going to do the screw tap for tapping holes. Okay. Click on this. We now have to size the screw tap. So we'll go ahead and see if it lets us do it now. Custom, expression editor, varset, inside top tap diameter. Okay. And we should get that. Okay. Now we're going to have to set the height or the length of this thread. The length of this thread, the length of this die, we're going to actually tap into the lid the bottom threaded height plus 1 millimeter. By doing that, it'll give us an extra turn on the top. So we're going to go here to the length, enter the expression editor, varset, body thread height plus 1 millimeter. So we will have an extra millimeter to screw down the top tightly. Okay. Now we have to move this in the Z direction. So how far up? Well, basically it's going to be through, we're moving it up the length of the size of the tap. So we're going to go to the placement, position, Z direction will be varset, body thread height plus 1 millimeter. Okay? And that should move the thread all the way up into the lid. Okay? Now we have to cut out the the tap. So we're going to take the cylinder, select the tap, go back to the part design workbench, back to our model, top, screw tap, Boolean, cut. Okay. Now we've cut the screw tip, the screw tap, and let's go ahead and make the threads true, and it should all be good. Now let's bring back the body by clicking on, the eyeball, and let's just for appearance, let's move the top up to where it belongs. And the position in this case, the Z is going to be basically the body height, right? Varset, body height, okay. And we can check ourselves by decreasing the visibility, increasing the transparency of the top. We have the top selected. We will toggle visibility. Oh, visibility, I'm sorry. I meant toggle transparency. Boy, you get to see me making all kinds of little mistakes. Okay, so let's double click on this, and you can see now we've got the extra millimeter of threads, and it all looks good. You should be able to now to 3D print this with no problem whatsoever. So now let's check ourselves. Let's go back to the varset. And let's go ahead and change the diameter to, let's say, 60. Let's say we change the body to 30. And let's say that we make the threads a little shorter, 4. See? All moves. So basically by defining the diameter, the height, you can create whatever size you wish for export to your 3D printer. Okay, folks, thanks. This is Steve here. Adios.